Dear students, grade 11. Today's lesson we're going to start about alcohols. First, let's take a look at the objectives that we have to learn about in this lesson. The learning outcomes, as you can see, first, draw and classify alcohols into primary, secondary, and tertiary. Recall the chemistry of alcohols in the following reactions, classifying alcohols into primary, secondary and tertiary alcohols, combustion, substitution to give halogenoalkanes, dehydration of alkenes, and deduce the presence of CH3, CHOH, which is ethanol, in alcohol from its reaction with alkaline aqueous iodine to form triiodomethane. Okay, these are the objectives for the whole chapter, but this chapter actually will be given to you in two parts. This is the first part of alcohol. First of all, we have to learn, let's remember, what is the general formula. For every homologous family that we have learned about, there was a general formula. Same here. For alcohols, there is a general formula of CnH2n plus 1, OH. This is the general formula. So using this formula, actually you can write any alcohol. Okay, imagine that N equal 3. So it's C3H2 multiply 3 plus 1 and OH. So this will lead to C3H, 2 multiply 3 plus 1, so it's 7OH. So here we have 3 carbons. What is the name of the third member of homologous family? So this is propanol. This is propane, right? Or prop. We said that the first part of the word, this is prop, which is the name of the chain. Okay, but also each of these names, especially for alcohol, we said that for each homologous family there is a suffix that it's written at the end of every name of every organic compound that belongs to this definite family or this definite group. So in this case, for alcohols, we end the name with OL. So propanol makes it alcohol. So first, let's learn about also the functional group. For each of the homologous family, there were functional group, except for alkanes that ends with A and E. Alkanes does not have a functional group because all they have with a single covalent bond between each carbons. But for alkanes, there were double covalent bond. Now for alcohol, we have OH, which is the hydroxyl group. Now let's learn how to name these. As usual, there are the same steps that cannot change. First, you have to choose the longest chain. Okay, and you start closest to the functional group. In this case, let's try this example. Okay, in this example, we have no branches, only the parent stem. Okay, the parent chain. The parent chain, of course, we're not going to start counting from this side. We're going to start counting from that side because actually this is the closest to the hydroxyl group, which is the functional group. This is our functional group. Here. So this is 1, 2, 3. Now, when you're writing the name, first you have to, of course, if there is any branches, you have to write the name of the carbon with the branch, and then the name of, the prefix, which is the name of the chain, and then you add the suffix, which indicates the functional group or the group in general. But in this case, we don't have any branches, so we will start counting from this side, from the right side. So here we have 1, 2, 3 carbons, and the functional group is at carbon 1. So the name will be 1, and since we have 3 carbons, so it's prop. Okay, this is the first or the name of the stem. Okay, and then we add OL, which indicates, or it's showing that this suffix actually belong to alcohols. So it's 1-propanol. 1 represent the number of the carbon that carries the functional group, and then the name of the stem, and just add the suffix. You can write it in another way. Just write the prefix prop, which is 3 carbons, and the number of the carbon carrying the functional group, and then OL, which is the suffix that indicates that this is an alcohol. Okay, let's try another example. This is a skeletal formula. Okay, starting from this side, that side, it doesn't matter because actually it's in the middle exactly. We have 1, 2, 3 carbons. Again, in this case, we have to write first the number of the carbon, which is 2. So we have 3 carbons, so it's propane, propan, and then we add the OL. This is alcohol, this is our prefix, this is our suffix, this is our prefix. Okay, or we can write it the same way, prop to ol. Okay, of course you can use the easiest for you, which one you can see fit. Okay, now try these compounds. Look at these compounds carefully and try to name them. Okay, I will help you do the first one. Okay, we said we start counting closer to the functional group. Okay, the functional group, if we count it from that side, so it's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, but if we count from the right, it's 1, 2, 3. So actually this is closer, so it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, that's a long chain. Do we have branches? Yes, we do. We have 2 branches. Okay, these 2 branches found in 5 and 7. So it's 5, 7, di, because it's 2, methyl, which is alkyl, and then you write the prefix. Okay, we have 9 carbon, so this is non, nonanol. Okay, something is missing here. Okay, nonanol at which carbon is the hydroxyl group? Okay, so here it's 3. So 3, nonanol. So it's 5 and 7, dimethyl, 3, nonanol. Okay, the second one, actually, I think you can do it by yourself. You're good for it, but there is a trick. Here we have 2 functional groups. So we write the name, but it's diol because we have 2 alcohol, or 2 hydroxyl groups. Now let's try the other way around. Here we have to draw the structure of each compound. Now this is much easier, and you have said that before. Okay, we have 2 hexanol. First, let's look at the prefix hex, hexane. Hexane, this means that we need 6 carbons. So it's 1, 2, 3, 4, 5, count, and 6. And remember, we said that each carbon has to have 4 bonds. Okay, so complete your 4 bonds first. Okay, now this is up to you. It's 2 hexanol. This means that the functional group is at carbon number 2. So this is up to you. You can start from this side, that side. Actually, I will start from that side, from the right side. So if this is 1, so this is my OH. So now you can fill the rest with hydrogens. And there you have your alcohol compound. So this is the displayed formula, and also you can write it this way: CH3, CH2, CH2. How many CH2s there? Okay, 1, 2, 3, CH2, 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 CHOH, and then CH3. Now let's check. 1, 2, 3, 4, 5, 6. Wow. 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, 8. Oh, well, we only need 6. Okay, CH3. Okay, so I think you can try the other one with the same, it's the same idea, but here you have a branch. Okay, now let's talk about alcohols. Actually, alcohols are classified into 3 types. First, we have the primary alcohols, the secondary alcohols, the tertiary alcohols. What is primary, what's secondary, and how can we define these? How can we differentiate between them just by looking at the compound? First, the primary alcohol. The primary alcohol where carbon actually is attached to 2 hydrogens, okay, and only 1 carbon. So you can, the R represent alkyl group. Okay, let me make it clear. For example, look at this example. We have CH3, C, H, H, and then OH. Okay, look at that carbon attached to the hydroxide. Okay, this is H. Okay, this carbon have 2 hydrogens. Okay, 2 hydrogens. So this is primary. When the carbon attaching to the hydroxyl group carries 2 hydrogens and 1 alkyl group, actually this is a primary alcohol. Okay, let's take a look. This is the carbon attached to the OH. Look here, it has 2 hydrogens, so it's primary. Check. Again, look at this one. This is the carbon attached to the OH. Also, it carries 2 hydrogens, so it's primary alcohol. It's 1-butanol. So, again, the primary alcohol, each carbon is connected to 2 hydrogens and the hydroxyl group, alkyl group. But focus on the carbon attaching or bonding to the OH, and it has 2 hydrogens. Now the next one, the secondary alcohol. Okay, instead, remember the first one has 2 hydrogens? No, this is different. The carbon has only 1 hydrogen. So, an example, CH3, this is our carbon, and this is our OH, and here there's CH3, and here there's just hydrogen. Okay, so in this case, we can write it also like that, CH3, okay, and then CH, CH3, OH. Okay, look at it again. This actually we can call it a secondary alcohol. A secondary alcohol, the carbon bonding to the OH group have only 1 hydrogen and 2 alkyl groups. Let's check another example. Look at this example. Look at the CH. Okay, when you're looking, just focus on the carbon attaching to the OH. Okay, this is the carbon attaching to the OH, and count how many hydrogens that are there. There is 1 hydrogen, so sure, this is secondary. Again, don't look for that side. Look for the OH and the carbon attaching to it, bonded to it. Okay, and here, 1H, guilty. It's secondary too. Now to the tertiary. A tertiary alcohol is when the carbon actually is not connecting to any hydrogens. All it has is just alkyl groups. So if we have CH3, C, CH3, CH3, and OH, can you see? There is no hydrogen here, only carbon attached to other carbons. So The general formula will be R3COH. There is no hydrogen attaching to that carbon. Okay, look